Let's start with 3. It's 3, 5, 12, I believe in the, let me take a picture. 3, 5, 12 are the first 3. Yeah. All right, so the key here is set up the table, right? And once you set up the table, everything else falls into place. So we have 2 trains traveling towards each other. So here is, and it's 195 miles. And we have a train going this way and a train going this way on parallel tracks, right? And when will they meet? At what point will they meet? So let's make this a little bigger. Right, so we know that. So one train's going to cover, and now this is just an example. One train's covered this much, and the other train's going to cover this much, right? So what does that tell me? It tells me that the combined distances from train A and train B will equal to 195 miles. So that's, you already know how to set up the equation. Oops. All right, so what do we have? We have DRT, sorry, RTD, right? Because distance is right times distance, and we have the slow train, and I'll go call the slow train, and then the faster one. The slow one rate's 25, the other guy's at 40. We don't know for how long they'll be traveling, but I know the distance is measured by the rate times the time, and then 40 times the time. So this here, okay, represents the distance covered by the slow train, and this one, the distance covered by the faster train, okay, given a particular time. And that's what we want to find out. So 25t, the distance of one train, plus the distance of the other train, guess what? Those two distances combined will give me 195. And we can combine like terms. 65t equals 195 divided by 65 divided by 65, and t looks like 3. Yep, it's 3. So now I can go back to my table here, and well, what's the question? How soon will they meet? They will meet in 3 hours. So that's the answer. But if you want to take it a step further, so the slower train, who's traveling at 25 miles an hour, he's going to travel for 3 hours, and he's going to cover a distance of 75 miles. The second train is going to go 40 miles per hour, and he's going to travel for 3 hours, and he's going to cover 120 miles. So this train here, the faster train, covers 120. The slower train covers 75, and the combined distances of each other equals to 195. Right? That's just a little more reassurance that we did our problem correctly, and it's correct. Where are we? 5, 3, 5, 12. Okay, so passenger train, a freight train, they're going towards each other. So again, same scenario. So, but this time the distances between both trains is, let me write just that this is 300 miles. So one train is going this way, okay, and the other one is going that way, and they meet. No, and we have the time. They go for 4 hours, and the rate of the freight train, the passenger train, exceeds the rate of the freight train by 15 miles per hour. So the passenger train is a little faster. So let's create our table. If we create a table, we can call this the passenger train. All right, passenger train, and then the freight train. And we'll get the columns, rate, time, and distance. So the passenger train is traveling at, it exceeds the freight train by 15 miles per hour. So, but we don't know what the distance or what the actual speed is. So the freight train is r, and the passenger train is whatever the freight train is plus 15. The time we know, they both drive for 4 hours. Now we get to express the distance, right, by multiplying rate times time. So this one we get 4r plus 60, and this one we get 4r. And now we can set up the equation. We know that the distance covered, so one train's got, obviously is faster, so he's going to cover this much, and the other train that's slower is going to cover a little bit less of a distance. But I know that this distance and this distance combined equals 300 miles. So distance of the train, of the passenger train, which is expressed by 4r plus 60 plus the distance covered by the freight train, which is expressed by 4r. Those two combined equals 300 miles. 8r plus 60 equals 300. Minus 60 over here, minus 60 over here. We get 8r is 240. Divide by 8, divide by 8. And rate is 30. So, who's 30? The freight train is 30. And if the freight train is 30, we know that the passenger train is 15 miles faster than that. So 30 plus 15, which gives us 45. And there we go. So again, we can use that, and we can, if you want to actually find the distance traveled by train, 4 times r, it would be 4 times 30. So the freight train covered 120 miles. And over here is 4 times 30 plus 60, which gives us 180. So the passenger train covered 180 miles. Freight train 120. And we know that combined, they should equal to 300. So, again, we know we're good. What's the next one? Let me just go back. The next one is 12. All right. Move down to 12. Okay, so we have a family went to a resort at an average speed of 30 miles per hour, and then return over the same road at an average speed of 50 miles per hour. Find the distance to the resort. The total driving time was 8 hours. Okay, so let's call this the house, right? Here's the family house, and here's the resort. Oops, resort. Okay, so they went this way at what are we doing? Wait a second. I'm reading the wrong one. Sorry, I was reading number 11. So 12. As part of his flight training, a student pilot was required to fly to an airport and then return. Okay, so here's an airport. Right? And then here's the other airport. All right, so he went to this airport and then he returned. On his way there was 90 miles per hour. And returning was 120 miles per hour. He probably had the wind behind him. Find the distance between the two airports if the flying time was 7 hours. Okay. So let's create a table. And in this case, I'm going to call this going to the airport, and then the second is going to be coming back. Coming back portion. RTD. Going, he was at 90. For a time, does it give us a time? Yeah. The total flying time was 7 hours. Okay. But I don't know how long, so the total flying time going and coming back was 7. So but I don't know how much of the 7 hours was going and how much of the 7 hours coming back. So let's just say, let's call that the going time was 7, it was T. It took me T hours to go to that airport. So if it took me T hours to get to that airport, and I know the total was 7, so on the return part, obviously it was going to be 7 minus the going part, right? 7 minus T. What was the speed here? 120. Now we can finish the last column. So this is going to be 90T. This is going to be 840 minus 120. Okay, so what do we know about these two distances, right? What do I know about the distance going to this airport and the distance coming back from that airport? Well, the distance has to be the same, right? The speed might be different, but the distance covered was the same. So different distance going, which is represented by 90T, is equal to the other distance, which in this case is represented by 840 minus 120T. Variables on both sides. Let's get rid of the minus 120 by doing plus 120T. And then plus 120T here. This goes away. I'm bringing down 840, and this is going to be, let's see, 0, 1, 210T. So now we can 840 divided by 210, divide both sides by 210, and T equals 4. So What does that mean? It means that the going portion is t, which is just, so I'm going to write here that the going portion took me 4 hours. And if the going portion took me 4 hours, the returning part would be 7 minus 4 hours, which is 3 hours, right? Obviously, it's less because the speed was higher. Find the distance. I'm still not done. So now I can go back to my distance column. This is 90 times t, so 90 times 4, which is 360 miles. So, and if you wanted to use the bottom expression, you could have said 800 minus 120 t, which in this case is 40. 800 minus 480. And 800 minus 480 is indeed 360. So it didn't matter which of these two you used because the distance is the same. What was that, 15? No, that was 12. I think next one is 15. Look at back. Yeah. 12, now it's 18. Apologies. So let's go to 18. A jet plane traveling 600 overtakes a propeller-driven train which has had a 2-hour head start. The propeller-driven is traveling at 200 miles an hour. How far from the starting point does a jet overtake the propeller-driven train? So it's that same problem as Vinny, right? Where he got to a head start and I had to go and catch up to him. So same idea. So create the table. What is it, jet plane? Yeah. RTD, and let's call this the jet, which is the faster one, obviously, and then the propeller airplane. So the jet is traveling at 600 miles an hour. The propeller was at 200 miles an hour. Now, the propeller had a 2-hour head start, so he's been traveling 2 hours more. So we're going to call the propeller T, right, plus 2 hours. And the jet is just T. 600T, if you multiply R and T, gives you the distance. And then here we have 200T plus 400. What do we know about the distance that the jet traveled and the distance that the propeller traveled? Well, eventually when I catch up to Vinny, or when the jet propeller catches up to the propeller, the jet airplane catches up to the propeller, the distance is going to be equal to each other. So 600T equals 200T plus 400. We're going to subtract. Here's my line in the middle, minus 200T minus 200T. That goes away. We're left with 400T over here and 400. And divide by 400, divide by 400, and T equals 1 hour. So we can go back to our distance column to find the distance, and if you multiply 600 times 1, which is the value of t, right, times 1, that gives us 600. If you use the bottom expression, 200t, or 200 times 1 plus 400, notice you get the same. So the airplanes, both airplanes obviously travel the same distance, which in this case is 600. 18, what's after 18? 20. Running at an average of 8 meters per second, the sprinter ran to the end of the track and then jogged back to a starting point at an average of 3. The sprinter took 55 seconds to turn to the end of the track and jog back. Find the length of the track. Okay, let me see if I understand the problem first of all. Okay, so there is a guy running, right? And he's going, where am I? 20? And he's going this way. And then he's going to turn around and come back. That's what he's doing. So this is, I don't know, let's make a wall here. So, create the table. And I'm going to going and returning. How's that? RTD returning. Okay, so going, he is 8 meters per second. Coming back, he's at 3 meters per second. The sprinter took 55 seconds to run to the end of the track. So the time going here was 55 seconds, so I'm going to write 55. This is in meters per second, so we can actually write 55. You don't have to write 55 or 60 because it's per second. Okay? Find the length of the track. And then here, we don't know. We're going to call it T, right? I don't know the time that it took to come back this time here. I don't know the return portion, which I'll put in blue. Right? Obviously, it took longer than 55 seconds because he's going at a slower speed. So let's get our D here at this column. So 8 times 55 is 440. 3 times T is 3T. Find the length of the track. So what do I know about these two distances? Well, I know that the distance going and the distance returned, they're equal to each other because they are the same distance, right? So our equation is going to be 440. The distance going is equal, right? 440, which is the distance going, is the same as the distance coming back, which is represented by 3t. We're going to divide this by 3, divide this by 3, and let's see what we get. 440 divided by 3 equals 146. Nope. Did I miss something? Sprinter took 55 seconds to run to the end of the track and jog back. Find the length of the track. So 8 times 55, 440. I'm getting 146, so T, find the length of the track. Give me a second. No, that's not the question. 8 meters per second. Oh, apologies. It's not 55 seconds that it took. Okay, so I got to erase this. It's not 55 seconds just to go to this, right from here. That wasn't 55 seconds. 55 seconds was the whole trip. Okay, there's my mistake. So, I don't know how long. I know the total was 55 seconds. So if I say that it took him T seconds to go from the starting point to the end of the track, then coming back, it would be 55 minus T, right? That's where my mistake was. I misread it. So on the top, 8T. At the bottom, 3 times 55 is 165 minus 3T. Same way we set up the equation. The distance going is equal to the distance coming back. Plus 3T. Plus 3T. That goes away. 11T, 165. We're going to divide that by 11, divide that by 11, T equals 15. So it took 15 seconds. And so now I can go back to my distance because that's what we want to find out. And you can plug in 15 either here or here, and it should give you the same value. So let's do the easy one, 8 times T or 8 times 15. 8 times 15 is 41, carry 4, 120. So this distance over here is 120, and obviously coming back, the distance should also be 120. And that's the answer. Next one. 22. 22. Motorboat leaves the harbor, travels an average speed of 9 towards a small island. So we have a boat. Let me put the boat. It's going towards an island. Right, so it's way there. He's going at 9 miles per hour. 2 hours later, cabin cruiser. I don't know what that. I don't know how to draw that. Let me make a bigger boat. Right. You don't have to draw bigger boat. And I'm gonna make it with like double engines. Okay. It's also going to the island. And he's traveling 18 miles per hour. And how many hours after the cabin cruiser leaves will the cabin cruiser be alongside the motorboat? Okay. All right, so at least you get an idea of what's happening. RTD, what is this called? Motor and the cruiser, which is the faster. The motorboat is 9 miles an hour. The cruiser is faster, 18. Time-wise, I don't know. Actually, take it back. I know that the cabin cruiser leaves 2 hours later, so that means that the motorboat's been in the water for at least 2 hours, right? So it's going to be T plus 2, and the cruiser is going to be just T. All right, so this is going to be 9T plus 18, and this is going to be 18T. How do we set the equation? Well, they don't, and let me maybe subtract this a little bit. So at some certain point, they're going to be exactly at the same side by side, right? So what is the distance covered by each boat? It's going to be equal to each other. So by the time the boats are next to each other, they cover the same distance. All right. Minus 19, minus 19. That goes away. 18, and this is 90. Divide by 9. T equals 2. So in 2 hours, the boat who took off later catches up with the motor boat. Okay. Is that what we want to know? Yeah. So what number was that? 22. All right. Next one. 22 is 23. Okay, 23. 23, a jet plane, 570 miles, overtakes a propeller train that had a 2 hour head start. The propeller train has 190, and then etc. Same type of question that we just did. So let's call that the Vinny problem. All right, so RTD, and this is the jet plane, and this is the propeller plane, right? The propeller plane took off first, had a 2 hour head start. So the propeller plane is going to be in the air for 2 hours more, right? So the propeller has been in the air for T plus 2 hours, and the jet plane has been in the air for T hours. The rate, jet is 570. The propeller is 190, so now we can find their distance. This is going to be 570 T. Do the Streeter property here, 190 T plus 380. Okay. What do we know about their distances? Well, the distances are equal to each other, right? Because the jet plane catches up to the propeller train. They have traveled the exact same distance. So 500 T equals 190 T plus 380. Variables on both sides. So let's get rid of the smaller one, which is negative 190 T. Subtract, right? Minus 190 T on the other side. These two go away. 380 comes down, and then 570 minus 190 is 380 T. This one's easy. Divide by 380, divide by 380. T equals 1 hour. What do we want? How far from the starting point? So again, we go to the distance column, and let's just use the first expression because it's easier. It says 570 times T, so it's 570 times 1, so 570 miles. So the answer to that one is that the jet plane travels 570 miles to catch the second plane. What was that? 23, I think. That was 23, so now we're on 26. two cyclists. Start from the same point and ride in. Okay, so we got one guy going this way and the other guy going this way. One cyclist rides twice as fast as the other. In 3 hours, they're 72 miles apart. So they start traveling, and then after 3 hours, after 3 hours, you say stop. And you stop here, and this guy stops here, and then you measure the distance, and you find out that they're 72 miles apart from each other. Okay, let's create the table. So let's call this bicycle A. Bicycle A goes this way. Bicycle B goes that way, or the slower and the faster. So RTD, let's call this the slow bike, and this is the faster one. One cyclist rides twice as fast as the other one. So the slow one is just R, and the faster one is 2R, because it's twice the slow one. Time-wise, they both travel for 3 hours. Now that we have those two columns, we can find the third column. So distance for the slow guy is going to be represented by 3R. And distance for the faster biker is going to be represented by 6R. Right? Because 2R times 3 is 6R. So what do I know about the distance of this guy and distance of this guy? Well, I know that if I add both distances, it's going to equal 72 miles. So there's my equation. 3R plus 6R equals 72. 9R equals 72. Divide both sides by 9. R equals 8. So the speed of the slower bike rider is 8 miles an hour. And the faster guy, obviously, 2 times R, which makes him 16. Okay. That's 26. 32 and 35. I can remember that. 32. 32. A family drove to a resort. So, didn't I just do this? All right. So, house, resort. So they're going from the house. They take the car, go that way at 25 miles an hour, and then they have their vacation, and they go back home, but their speed is at 40 miles an hour. Okay, find the distance to the resort if the total driving time was 13 hours. All right. So RTD, so going to the resort, they were traveling at 25 miles an hour. Coming back, return, they were traveling at 40 miles an hour. Time. I know that the total time was 13 hours combined. Okay? So I don't know how long it took them to go, and I don't know how long it took them to return, but I know that combined is 13 hours. So let's call one of them T. So it takes them T hours to go. Well, the total trip was 13 hours. The return has to be 13 minus T, whatever the going time was. And that's the time column. Now we can do the distance column. Multiply R and T, we get 25T. Here we're going to multiply 40 times 13, which is 520. And then minus 40 times T, which is 40T. What do I know about the distance going, the distance coming? Well, the distance going and the distance coming back from the resort are equal to each other. So the distance going is represented by 25T, and that equals to the distance coming back, which is 520 minus 40T. Variables on both sides. Let's get rid of the minus 40 by doing plus 40. And I'll do plus 40 over here. T. That goes away. 520 is the only thing left over, and then this is 65T. Divide by 65, divide by 65, and T equals 520 minus, divided by 65 equals 8. So I know now that going was 8 hours, which means that coming back was 5 hours. Is that what I want? No. Find the distance. Well, the distance, well, I can just take that and go to distance column. Let's just use the simpler one. 25 times t, or in this case 8, and 25 times 8 is 200. So the distance going to the resort was 200 miles, and obviously coming back from the resort has to be the same. And you can plug in 8 over here, and then let's just do this. 520 minus 40 times 8, 520 minus 320, and notice that you get the same exact answer. So, right? And that makes sense because the distance coming back is the same. Okay, 32, and then last one, 35. So see, this is not that bad. Drawing might help. So student walks and jogs to college each day. The student averages 5 hours walking and 5 kilometers an hour walking, 9 kilometers an hour jogging. Distance from home to college is 8 kilometers, and the student makes a trip in an hour. How far does a student jog? Okay, so we have RTD, and let's call this walk and jog. Walk and jog. So the walking part, guys, 35. So a walking part is 5 miles, 5 kilometers an hour. The jogging is 9. The distance from home to college is 8 kilometers. So the total distance from home to college, from the distance from home to college, 8 kilometers, and the student makes the trip in 1 hour. So let me make a little drawing here. Here's his home, and here's the college. So part of this, he walks, part of the distance he walks, and the other part, he jogs. Okay? We know this complete distance from the house to the college is 8 kilometers. Okay, and we want to know how far does the student, so what is the jogging portion, okay, of the 8 kilometers. Right? So the whole time from home to college takes an hour, and again, it's combined. It takes an hour. So I don't know out of the hour how much is walking, and I don't know how much of the hour is jogging. So let's call that the walking part T, and obviously the jogging part is going to be 1 hour minus T. And there is your expression, which we can find the distance. 5 times T is 5T. Distributed properly, 9 times 1 is 9, and 9 times negative T is negative 9T. Okay. So what do I know about the jogging and walking distance? Well, the walking distance is represented by 5T, and if I add the distance that he jogs, which is represented by 9 minus 9T, it's going to give me a total of 8 kilometers. Combine like terms, this is going to give me negative 4T plus 9 equals 8. Variables on both sides, no. Distributed property, no. Combine like terms, I just did. So let's subtract 9 from this side and 9 from this side. That goes away. I'm going to have negative 4T equals negative 1. I'll divide both sides by negative 4. And T is 1/4. So T, this one, is 1/4 of an hour, which means that the jogging part was 3/4 of an hour. So 1 minus 1/4 is 3/4 of an hour. Now I can I didn't need that, but I can take T, which I just found, and come back to the distance, right? Distance portion of my table. Substitute. I want the jogging part, so I'm going to go straight to this. So this is 9 minus 9T. So 9 minus 9 times 1/4. 9 minus, and 9 times 1/4 is just 9 over 4. 9 over 4 is 2 1/4. right? And if you subtract that, you get 6 3/4. Okay, is that what I wanted? Yep. And that's just to confirm the walking part has to be 1 1/4 because that would add up and make 8 kilometers. So if I take 5t, 5 times 1/4 is 5/4, and that equals 1 1/4. So we're good because this and this combined should give me a total of 8 kilometers. So the walking part, he walks a distance of 1 1/4 kilometers, and he jogs for 6 3/4 kilometers. All right, okay. That's it. That's it.